So I'm an AI project manager at TMC, which belongs to Unilabs, one of the largest diagnostic groups in Europe in the world. And we have a department, the AI Center of Excellence, where what we try to do is identify great use cases for AI, which solutions are out there in the market that can help our radiologists and pathologists work better. So we deploy these kind of solutions after evaluating them, and we ensure that they are delivering great value.
So this is a chest with IV contrast, a CT chest with IV contrast. This is the exam name. When you open up these folders or jackets or exams, you get series descriptions that are broken up into different planes of the image or the body, so that you can understand what's going on in a three-dimensional space, right? So you take these images of the bodies, and then we make all kinds of images out of the one scan, and there are different names for that. Well, this is a big problem because you have a very complex naming ontology applied to this, and this is surprisingly common. This is actually a default setting. So think about it, all these different manufacturers, all these different technologists, doctors, even individual rooms within one hospital, one CT scanner can call something completely different than another CT scanner, and that's the same thing with technologists. So it creates a lot of inconsistency within these series descriptions, and so we have another CT with IV contrast right here and a whole new set of ontology. So writing rules around this is next to impossible. And that means that a radiologist is going to go open this, and they're reading hundreds of these films a day. And you think, oh, there's the image, but what they're having to do is get their monitors in all kinds of different configurations because of all of these image types. They're spending 30 to 90 seconds every exam trying to get their monitor to display how it should. So what we've done is this algorithm, ENDEX, can essentially sit in between a modality or a CT scanner essentially, or an MR or X-ray. That's what we're up and running for right now, is CT, MR, X-ray. It can sit between the modality and PACS, or the archiving place where all these images are going to go live for a while. And it can understand what's going on and intercept, meaning it sits between, grabs the image, understands what's going on. So it uses our background, which is that computer vision, understanding the pixel data, knowing what's going on in the image, then understanding what's going on in the back end, so understanding the metadata and that DICOM data, doing a very complex set of calculations. And then we come up with clinically logical ontology that makes sense to go into these series descriptions and exam descriptions. So to somebody who understands imaging, this makes logical sense. And even better, it's consistent. So we won instantly with the hanging protocol. So instead of them having to change all their monitors or their thumbnails to be different images, they can now just go straight to reading, they meaning radiologists. And that's an instant win because they get capacity, efficiencies. They don't have to spend time doing that. And if you know, radiology is just getting busier and busier. We're taking more and more images every year, and it's not going to go down.
We have some preliminary data because quantifying the impact of a solution like ENDEX is a challenge on itself. But we have preliminary data, and what we are seeing is that radiologists are spending something like 1 to 1.5 minutes less reading exams. Okay, here's some of the data, and that's leading to a 10% efficiency increase, which means that radiologists are now reading the exam 10% faster because they don't have to drag and drop the images. And also that amounts to a 10% productivity increase. At TMC, we measure the productivity in rad units. Every kind of exam is assigned a certain rad units, which quantifies the work done. And since deploying and rolling out and having the radiologists adopt the SDPs after standardization, we are seeing this 10.4 productivity increase here. Here, what we have on this slide, these are examples of MR brains. So these are real study descriptions that we get. So as you can see here, just by looking at it, it's quite difficult to understand that these are MR brains. So if this doesn't work well, I mean, if this is the data that we're getting, then of course we cannot make the display protocols work because it won't be able to identify what's inside. And of course, we won't be able to route automatically because the word brain or the word MR doesn't really appear in there. After a lytic, that's how the study descriptions look like. So now you can clearly see that you're about to read an MR brain with no contrast. If you cannot control easily the way the studies and series descriptions are reaching you, you need something like ENDEX, because otherwise, I mean, how do you expect the display protocols to work? Or you can use these standardized studies and series description for so much more. Like you can get much better data analytics and understanding of what kind of volumes you are processing.
The PACS admin job is now much easier because Maria, our PACS admin, now doesn't need to worry that much about configuring one display protocol per client, per radiologist. Now when they don't work, now it's much easier to fix. Also, the amount of times it doesn't work has been really reduced. Now we get much fewer complaints from the radiologists that the display protocols don't work. And what's more important for us is that now radiologists are finally have some encouragement to use them because now they know that they work much better. If you're really thinking of solving the display protocol problem, and ENDEX is the way to go, and you're gonna realize that the deployment can be complex. There's a lot of technical challenge to be covered, but it's totally worth it because the ENDEX has a fantastic team, and they're gonna be super responsive, and they're gonna walk you through the whole process of deploying successfully.